started the recording as well.
So guys, are you able to see my screen?
Yes, I
Yes.
can.
Okay. So data engineering guys all started from Hadoop. If you remember, we had discussed in our introductory session, in the first session, how data engineering and how Hadoop and Spark big data ecosystem is different than the traditional ecosystems. Why we have to move to big data ecosystem and how that change has happened in past 10 years because of the volume of data. Now, because of the digitalization and the OTT platforms, we have to like find a ways where we can process the data, like high volume data, in a quicker way than the traditional way, where there are millions of records are not able to like query. The analytics and the business teams were not able to query the high volume data on SQL and all the traditional databases. Hope you guys have understood what Rajnish sir has told you about the SQL DB and all the concept of the database. Because from there, data modeling and the SQL queries are will be stick to you for like till end in data engineering part. Because in corporates you'll have to do query and to understand the data before proceeding and writing any ETL pipeline for it, for any projects. So today we will understand what Hadoop ecosystem is and how it has overcome the bottleneck of dealing with high volume data with the traditional ecosystems. Okay. So in SQL DBs, we know we are storing data in a structured columnar format, like create a separate columns and then storing data individually row by row in those tables. But now the foundation of Hadoop ecosystem is actually foundation of the big data processing platform. So it allows to process the data by increasing the number of resources for it. Because initially, if you say, for example, this is a SQL table. And to perform query on it, consider this is our this is our SQL query engine. Okay, so consider now we have a SQL table which has records of around 1 million records, and SQL engine RDBMS systems where we used to write the SQL query, where in previous lectures, Rajnish might have told you like how to do the select query, how to do group by and all the SQL syntaxes where you have performed and see the table, how it looks. So that is, you can consider as a SQL workbench on where you are trying to query your data. Okay. But what issue which actually we were facing before, the SQL query, even if I have configured, consider this single instance as like highest configuration I can give is consider 132 GB RAM. But even if having a 132 GB RAM, there is only one single instance. This instance, whenever I say instance means guys, consider as a CPU. CPU means like a system, a one machine. Okay. Machine or instance, because I'll refer it as an instance because in organization you will use this term instance. So to perform query on this 1 million records, the SQL engine is taking around 1 hour minimum, at least 1 to 2 hour, or sometimes depends on the data or conditioning which we have passing in the SQL query. It is taking that much time. But for example, business is asking you to give me a report for a sales which we have generated for last 10 years. So in that case, where there was a time like technical guys used to ask, we will able to generate that report by today end of the day, because the query will take time for it. Now business is not able to wait for that for each and every report for that longer, so they'll have to come up with a solution. So in that case, how Hadoop has came into picture, where it has created a new ecosystem, which we call it as okay. Let me clear this first. So ecosystem, we just call it as Hadoop. Hadoop ecosystem, consider as what actually at backend is. If anyone asks you how Hadoop works on map reduce. Wait, what architecture Hadoop follow is master slave architecture. Consider this is our master node. Master node, and these are all slave nodes. Okay, I will write it as guys slave 1, slave 2, slave 3, slave 4, and slave n means so on. So okay, now this was our source data. Consider it as either a SQL DB, SQL, or any RD BMS system. Okay, so as we know, we were not able to process query millions records in SQL DB or any RDBMS system directly. So what this Hadoop came up with, why can't we extract this data as a raw data as in a form of Parquet format? Because so far Parquet is the most fastest processing data format we have, and it is a very lightweight format than with respect to other data format like CSV, Excel, JSON and all. Okay. So how we can process that? So what it came up with, why can't we use this data as a raw format? Let's process it into a file system first, and then process it to process it faster. Let's use a distributed platform like distributed compute processing. Distributed system means, guys, it will perform its operations and split the operations in stages and split it across the cluster, across the resources within a team. So consider this whole entire architecture as a team where this person is a manager, which we are referring as a master node. In architecture terms, we can also refer this as a name node. These are all name nodes and data nodes. So this is data node 1, 2, 3, 4, and so on. Data node. Okay. So how it process the data is, it will read the data first. For example, if the data is a big size, okay. That's okay. Let me add one more step here, guys. How we can process it by distributing it. Okay, let's understand this, how the master slave architecture works, guys. Okay, so whatever the input task or any query, for example, we have performed a query. From here, we are giving an input request to this. Input request. So input request has came here, and there is a master who is receiving all the requests whatever we are giving to give us a, like, to expect for a result. We are reaching to someone, I want you to deliver me these results. So I just consider we are inputting as a query, a big query, to give us a results on a million of records. So what it will do, it will first it will read the query and it will see. And here there is one more person which is called it as Yan. Resource manager. So master slave, the master receives a request and it reaches to a Yan, help me to allocate a resource which will, there is an exchange between these two guys. I have received, this person will talk to Yan. I have received this request of my work. I want you to help me to find and see how many resources are available at present in our ecosystem, which will help me to perform this task and deliver the results. So what Yan will do, Yan has access to all these data nodes. Okay, guys. So what Yan will do, Yan will check what are the resources are currently available in our cluster, which will able to perform the task. So it will allocate the task. It will give the information back to master node that these many resources are available. Please hand over the activities or tasks to these people. For example, Yan has just checked how many resources are currently present, and it has found, sorry, it has found these many resources are available. Okay, so it will inform the master node that these are all first four nodes are available. Please hand over the task to them and let them perform. So these four resources, what they will do, they will go to the database and check to the source wherever the data is available at present, from where we want to perform that query. Either it is a S3 data, Azure Blob data source, like HDFS, and whatever the data source is there. So it will go there, it will check, it will split the task, whatever the task has assigned, because master, this one will be distributing the task to our slaves, and the slaves will perform, and then it will go back to master node. Now here comes play a mapper and reducer. This is also referred as a guys. 1 minute, I'm getting a call. Yeah, sorry guys. First, let's understand the master slave architecture. Now you guys understand this part first, the master slave architecture, how it works actually. Because based on that, then we will continue with map reduce. because if I include both, then it will be difficult. It will make confusion. So I thought to avoid that. Are you able to understand this part, guys?
Yes.
And here the output results will be delivered. Output results is okay for now. Just understand this part. So now you understand, guys, what a yarn does. But now you think about it, guys. There might be a situations where any of the systems will go down because of network issue or any technical glitch. If any of the systems are consider the four systems are currently doing a task which the master node has allocated to them. So it is not just allocated to these people. Whatever the tasks are allocated to these people, guys, the tasks are replicated 3 times into cluster for other resources as well. So that if these people, any of these tasks or any of the resources will go down, what yarn will do, yarn will allocate that part in that task into different one to where the image is replicated. Image means what the task image, whatever the task this currently this instance is doing. Okay, so all the tasks are replicated 3 times within a cluster, like into three. So if all together also this one instance, this guy and this guy, both will go down due to technical issue. There might be a situation in cluster, like some of the nodes are not responding to the master node, because and how the master node will know which are the tasks are currently working, because internally they are keep exchanging their heartbeats to resource negotiator. The full form of yarn is yet another resource negotiator, because yarn is the one who is managing all these resource exchange activities performing within the cluster. Okay, so yarn will take care of all the resource negotiation, whatever the resources are working, whatever the resources are not performing well, let them move to new resource, let the task, they will allocate the task. If the resource is not able to fulfill properly or able to perform the task, it is just handing over the task to another available resources. If this resource is not performing well, or like it might be a situation due to network or any technical glitch, this resource has failed to run or share its heartbeat to yarn and master node, then yarn, what yarn will do, yarn will turn off and turn this or hand over this task to this resource from here to here. You understand, guys? Just have a
It's
quick look on it, guys.
the last one. Can you please explain the last one?
Okay, so consider this resource. Okay, you remember four tasks were available, four resources were available. Consider this four from S1 to S4 are currently working on a query which input request we have received. Okay, this team, consider this Hadoop team is working, and it is a manager of Hadoop whose name is position name as master node, and the employees which are working under him are slaves. Okay, slave nodes or data nodes. Okay, so for example, the master, and every time you remember in organization, actually we day to day we take a stand up calls to share our exchange our performance update, tasks update. So it is similar way, all these four resources currently working on a project Consider this input request is a project which they have received to deliver. Okay. So this project, this manager has allocated 4 resources to that particular project to deliver. What happens suddenly? This project, one resource is suddenly went on leave. Went on leave means not working, offline. No technical, no connection, technical glitch, no network error, not able to connect. Now 3 people only rest for that project. So what manager will do? Manager will check with Jan. Jan is a resource negotiator we have. Consider this person as an HR, resource manager, who knows what team is working on. So in this team, every team has an individual HR, you can say, resource manager. So resource manager knows these 4 people are free currently. Can you please use the slave 4, slave 6, slave 7, any of them? So master will check slave is available, hand over this to him.
So Yarn is the resource negotiator, right?
Correct.
He will check among the rest. Okay, so we have 4. अरे मुझे पता नहीं क्यों confusion हो रहा है. So we have 4, 1, 2, 3, 4. Second wala is not available at all for any reason.
Yes.
Now this master node will tell Yarn that one of the out of 4, the one of the person is not able to perform, so we need one more. So
One
he
more.
will check with 5, 6, 7 or the other ones, not with these 3, right? Because they're already working, है ना?
Correct. These 4 are already working.
हाँ, मतलब 1, 3 and 4 are already occupied.
Occupied. They are working on a project already. Whatever
They're
the
already
task
working and
allocated to
one of the
them.
team member left away for any reason.
Correct. Consider
So
technical glitch, shutdown, not able to connect or
every
resigned.
possible reason that he's not able to do the task on that day. And
Yes.
then out of S5, S6 and slave 7 and the remaining who's the n number of resources, Yarn will, so master node will ask Yarn to allocate one of the resources as a substitute for S2, right?
Yes. What Jan has, the information Jan has is availability of resources.
हाँ. तो okay, master node will talk to and communicate with Yarn. हाँ, ठीक है.
Correct.
ठीक है,
Because
फिर
whatever the information, what slave 1 is doing, he knows. What S2 is knowing, he knows. Master node don't know what this person are doing. Jan is the one who is assigning what and whom. Consider Jan, the information Jan has is
not available to the master node. Yarn will allocate the best possible resource, है ना?
हाँ.
ठीक है, clear. Okay.
Like slave 1 is doing task 1. Slave 2 doing task 2. Slave 3 doing task 3. Slave 4 doing task 4. Okay. Okay. So suddenly slave 4 has left. Slave 4 left. So let's move the task from slave 7 is now doing task 2 because somehow slave 2 is no more. Okay. Got it, guys? You remember there is a image has been replicated within cluster to all the available resources already. Means if anyone go down, they have an image. So this instance has 3 images of each of task. So how this, because you should have a question, what this person know, what this person knows, what he is working on. Because the logs has been shared with them as well. internal logs, like you can say the task images what they are working on. So he will continue the task from where it left. It's not, it doesn't mean he will start the task from beginning. He will continue the task from wherever it has been kept on hold because of his unavailability. He will continue from then itself.
Because the other nodes have the information, right?
Yes.
About each node, what they are doing.
Each node. हाँ.
मतलब अगर 100 नोड्स हैं तो सबको एक दूसरे के बारे में पता है.
Correct. At
But
least
that's true, sir.
some,
हाँ.
not everybody, at least 3 of them should know
Okay. मतलब
what
minimum
he is
3 तो होने
working
ही
on.
चाहिए.
At
ठीक
least
है.
3% should know. That is the minimum criteria to maintain the 100%, 99% accuracy and availability.
Okay.
Okay.
और अगर ऐसा
The,
कभी होता है क्या कि वो तीनों रिसोर्स लेवरेज कर लिए गए फिर तो कोई नहीं बचा और फिर सिस्टम में
नहीं
प्रॉब्लम आई तो?
नहीं. So in that case, the tasks should be in queue because it is not 100% resources are always allocated. Jan will take care of it that at least 20 to 30% resources should be free for any uncircumstances or any
Okay.
unexpected situations to deal with.
Okay. Okay.
If all of a sudden everything goes down.
Okay. Okay.
Okay.
Makes sense. Okay.
Yeah. But there is one more big thing. What a master node is itself go down. If master node, this guy, master node. If due to same technical issue, this person itself go down, then how the rest resources will work? If manager is already resigning, who will take care of team? The situation end up like this. In that case, we maintain a backup of secondary master node, guys. This part you guys understand? Shall I remove for now?
Yes, yes.
This is a secondary master node. Okay. In this situation, when this master nodes go down, all the works, because you remember Jan has all the information of cluster. Jan is a resource negotiator within cluster. So whatever the information Jan will hand over to this master node, secondary master node, and it will shut this guy. Now he is the manager. Okay. Now this is the and he is our primary manager now. Okay, guys. And he has all the information. Now Jan is talking to this guy. But guys, Jan can only hand over the information which he has, but how he can change the master node within it? So for that purpose, there is a guy who is managing, who is taking care of master node, that is zookeeper.
This Kafka and Zookeeper. This one, right? Kafka is
Zookeeper,
different.
the sorry,
नो 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 एक कुछ काफका और जूकू कीपर भी होता है वही है या फिर वो डिफरेंट है
Kafka is different. Kafka is for real-time processing.
हम्म
Zookeeper is who is taking care of master node, means who is having information of master node. If any master node, primary master node goes down, he should be responsible to take care of entire team, should be working at any condition. So it's zookeeper's responsibility to make sure everything working below him should be working all the time. So in case of master node go down, he will allocate, if for example he has both working, one is on, one is off. Okay. Just consider it like this way. Now at present, this one is off and this one is on. Okay, guys, because this master node is not able to perform, or he is having some technical glitch due to which a delay or any error is perform is like zookeeper has identified is there is a glitch with this guy master node. So he just same time he turned this off and turned this guy on to take up and continue the task now. Any question, guys? Any question, any doubt, please? Because this is the most fundamental understanding of big data engineering, guys. Based on this only, rest other things will be able to understand. Because the primary questions would you'll have to understand is why we move to big data, why we go for a distributed processing systems and distributed engines, why we are now why we need to use clusters and all. Because based on this fundamental only, rest other things are like has been developed and evolved to enhance this entire ecosystem only. Because this yarn, initially yarn was not there when the Hadoop has started. Hadoop has started with only HDFS and this MapReduce has some limitations, has some bottlenecks. So to overcome those, yarn has come into picture. So let's create one more tool which is called as yarn, who will have the information of all the resources available in the cluster and who should be able to take care of resource negotiation within cluster. Now then, Jan introduced, and there was some one day suddenly in an organization and in a project, master node has suddenly shut down in production. The whole project has suddenly shut down. Then they found it is a bottleneck. Yeah, like if master node is go down, then everything is shut down. We need to do something for it. Then they come up with a new feature or new tool, which is a zookeeper. Let's create a one more guy who will take care of master node also. So this way, zookeeper is just switching the master nodes to switch off, switch on, switch on, switch off. It just do this. Consider a team has two managers. One manager would be present in absence of another. All the time, team is working 24/7. Is it okay, guys? Clear?
yes तो ये बेसिक्स ऑफ हडूप इकोसिस्टम लिख सकते हैं क्या सीवी में?
Yes. What is a Hadoop? They will ask simply. You just have to tell them Hadoop is just a master slave. What architecture, processing, execution Hadoop follows? You just have to tell master and slave architecture. What Hadoop
Okay.
actually works on? Hadoop actually works on MapReduce. And I will give you, now we will go for that MapReduce thing. Rest other guys, are you able to understand this part? Please ask any questions. So all clear guys?
Yes, sir.
Okay, now we will go for what is MapReduce. Now we are going deeper into this architecture guys. How internally it is working is, it is working as this way, MapReduce. How the data is processing internally is input request for a query. This section is totally, these are all mappers. Reducer. Consider mapper means these are guys, this. The operation performing by all these slaves, okay, are nothing but a mapper. Mapper means, guys, for example, the query which we have performed on this. For example, a SQL query, input received, select all from employee, group, department. Select let's count. For example, we have to perform a query. We have to count how many employees are there in each department. Okay, guys. Calculate total employees in each department. Okay. For example, just for example, guys, no, we have total 5 departments. Okay, guys. So now consider, now we have a total 5 departments. So you know how master slave it will distribute it. This is all the distributed system where we are distributing tasks to each particular resource. So now as we know, for example, in table we have already know 5 departments are there. So to count a department in one, to count total employees present in that particular department, let's us allocate this task into 5 people instead, dedicating this entire task to one person. Okay, are you with me, guys?
Yes.
So input received, the master slave architecture as following. He is allocating the task to 5 resources to determine, to calculate total employees present in that, in each department. So consider like IT department. So they have allocated this guy to calculate all employees for IT department. Okay, mapper to allocated task to admin department, and let's see HR department, make it how many people, finance department, finance or management, and consider this guy is taking care of which other one more department is like CSR. Okay, so consider these are different 5 departments. Now if a one person is going to do this task, it will obviously taking a longer time than splitting this task to every individual working for a specific department. You agree with me, guys? If one person is going to perform this task, counting total employees present in each department, will obviously be longer than splitting every department and assigning a task to calculate all the employees present. So this way, mapper is mapping a task to resources internally, and the reducer is the one who is actually, if for example this mapper has mapped and assigned the task, and now reducer is the one who is reducing means minimizing the output as a one format, because this all people come up with a separate information, right? Who will be there to combine this after delivering, guys? Someone need to be there between, after this execution has performed in all the mappers, guys. This guy has delivered a result, this guy has its own result, this guy has its own result, everyone has their own results with them, output with them, but we need someone to combine the result and generate it as a output format, requested format, in which output is requested in a tabular, like how the output will be. Okay, let's see. Okay, IT has 400. Let's create output table. Output table looks like department and total count, total employees. Department IT has 400. Next, HR What is it? Yeah. Employees. IT, HR. Management and CSR. Yeah. 400. 12. Finance 36. Management has 20. CSR has 8. So this is our output result, guys. Result. Guys, have a look on this and pay attention and see if there anything missing. Is there anything there? If there is there any way where there can be a chances of having an issue, or are you having any doubt on this? Any questions on this, guys? Or if you're not able to understand this? Is this part clear, guys? Mapper part? Mapper and reducer. What reducer is doing, what mapper is doing. Mapper is just mapping the tasks, and reducer is the one who is getting the who is actually collecting the results from each individual and combining it and then delivering it as a one result, because these are all the result is in a currently distributed form. One results 1 2 3 4 5 6, because 5 tasks are there, are all independent tasks. Now he reducer is the one who's combining all the results and delivering it as an output. Hope this part is clear, guys, because this too is the major foundation, like most foundational of data engineering concept, guys. This distribute, because they in interview they might ask how distributed system works, how parallel execution happens in cluster, who is taking care of all the execution, how the distributed results are getting combined, who is taking care of what map reducer do.
Aditya, we have one reducer all the time, right? Who?
It's not about we have one reducer. Reducers are always lesser than mappers.
Okay. Like as
There
an
might be, we
entire
can have
entity,
two reducers.
we can, okay, okay, we
We
can have
can,
more.
because here we have two reducers. Consider each box as a one single instance, one single person.
Okay, not as a
And then,
whole.
not as a whole. I'm just boxing it to understand it is these are all mappers, these are all reducers.
Mm-hmm. But then how these different reducers communicate with each other? Like
Because they are
this
in the
internal,
same network. They are
they are in
also
the
same.
same net. Suppose जैसे कि ये M1 M2 M3 है,
Hmm.
फिर इसका आउटपुट ये R1 के पास है ना?
Hmm. Hmm.
अब M3 R2 जो है वो M3 M4 M5 को हैंडल, मतलब ये कैसे एलोकेट होते हैं रिड्यूसर्स, किसको क्या कैसे? अगर R2 के पास M3 M4 और M5 होता और R1 के पास सिर्फ M1 और M2 होता.
So these are all working inside this, guys. Means how this is performing, it is all this exchange between resources, exchange between everything
अच्छा, मतलब
is
इंटरनल लेवल पे ये
yarn
इंटरनल
size.
कम्युनिकेशन होता है.
It is all happening inside this master slave architecture,
ओके, ओके,
because
मतलब
this
इसमें
I'm
हमें
just
दिमाग
now,
नहीं लगाना, राइट?
we don't have to do anything here. It is just a concept to understand, because we have, while configuration or troubleshooting any issues, we should know how things are working at backend and what could have been caused the issue here.
इसका आप एक रियल टाइम एग्जांपल देंगे जो आप काम करते हैं उसके बेसिस
This
पे?
is the real time example, guys. I have given a query to my class, to my job.
ओके,
This is a
ओके,
query I have given to my job. Key, calculate each employees present in each department. Calculate total employees present in each department. So it has, so this mapper means the resources behind this mapper means, consider this mapper belongs to this guy. Map 2 belongs to this guy. 3 belongs to this guy. 4
ओके.
belongs to this guy. Consider the task. You remember here I was talking about a
हम्म.
tasks. Every individual is doing a tasks. So from task, from that layer, this comes into picture, mapper reduce. Now we have
Okay.
received a task, means received a input request, input requirement, request. From there, the exchange between these people, how it looks is like this. Because here, every individual having its own independent task. There is no relation between, because in this node, this guy don't know what S2 is doing, because if these four people are all together working, they don't know about each other. Somebody outside this umbrella will know, like these are the free resources, they have the images of what he is doing. Allocated
Yep.
resources don't know what the next allocated resources is doing,
Okay.
because they are occupied with one particular task at a time, always.
Mm. And this is
And
how various nodes are doing, slaves are doing
correct,
are working
correct,
parallelly, right?
yes.
It is somewhat similar to the OS concepts, right? Like parallel
Sim,
processing.
not
Somewhat. I mean, it's
we
okay.
can.
Yeah, but ठीक है. ठीक है. Thanks, Aditya.
So this is how the distribution framework is come into picture, guys. Distributed framework, also we can call it as parallel execution engines. And now this end up with the SQL part. Now, why can't we use a programmatical language also to perform all these activities? Why only we keep to this one, SQL? Because Hadoop has end up with the Hive. Hive is a SQL data warehouse, guys. Provide a SQLite interface to query, manage massive access data sets in HDFS. HDFS is nothing but, guys, now let's talk about, let's come to next topic, that is our HDFS. Right? Wait, let's talk about Hadoop here. Hadoop distributed file system. It is nothing but similar to our file manager, guys. You remember, we have a file manager in our phones where we can create a new folders. Let me show you how it looks, guys. Okay, this is all the HDFS. Everywhere here you can see, guys, the master slave architecture. Okay, you see the name node, the data nodes. How distributed file system works is, it stores the data, it replicates the data inside in as a files, means object storage also we can refer it as. This local disks means the storage system, guys, the storage space. You see here, guys, where the data lake. This is the backbone of this Hive, because Hive don't have a storage space. It uses Hadoop as a storage space. You see, distributed file system, a storage layer, it is by default, it is a fault tolerant file system that breaks the large file into small blocks and distribute them across thousands of servers. Means thousand of server means our cluster. This ensures the data is safe and highly available. Now I will show you how it stores the data as well. Now let's skip this part, talk about same architecture goes here as well, guys. That's the reason I have used these terms as well, name node and data node, to continue here. Yeah. Name node. Okay. So these are all consider. Do you know, guys, what is the RAM and ROM? RAM and disk in your phone. What is RAM? What is ROM? So guys, understand HDFS, how it stores a file in a distributed form. Okay, consider we have a file. Okay, consider our ETL job has extracted the data from source. What is source here, guys? This one, our SQL server. Source. Source means data source. Now our ETL job has extracted the data of 40 GB, and now we want to store that data into our file system. File system means a data lake. This is actually a data lake. Data. Just keep this topic. We will continue. We'll dive into this more into our next session. But now just understand this is as a data lake or a raw data, centralized data repository, data warehouse. Warehouse, no, we cannot call it a warehouse, but consider as a file storage. This is our file storage of big data ecosystem, SDFS. So we have received a file of 40 GB. Now this request has come here. Okay. Here now we have the metastore. Metastore has the information of the data present here. Name node means it has all the information of data which is stored inside our data. Consider this, you can refer it as a big data database, but we call it as a file storage system. Okay, distributed file storage system. So HDFS will distribute this file into the number of resources for storage available. Distribute. Consider this as instance machine 1, machine 2, machine 3, machine 4. Okay, guys. It has a capacity of, let me keep it this way, like 124 GB machine. Because we are working on a big data, so machines are higher capacity, like higher storage. So all individual machines are having a capacity of 124 GB. The input files are getting splitted here into 10 GB each. 10 GB. So this way the overall 40 GB of files has got split into 4 partition, or like in 4 splits, so that we can distribute that storage into our cluster. Because why we are distributing it, if we store one file as a 40 GB, to perform operation on one file of this heavy size will take longer than to perform any action on the smaller size file. You understand, guys, this part? Why distribution is helping here and enhancing our performance and like execution, faster execution. Please be attentive, guys, or else. Anybody? Am I audible, guys?
Yes, you are audible.
Okay, cool. Yeah, so this way the distributed storage system works, guys. Whatever the data we have, we are splitting it into entire cluster, and to maintain the 100% accuracy, it is just a 4 systems I'm saying, but we do have a replica of this size into 3 other instances as well. Consider this cluster have total of 32 disks. Out of which 4 are in front of you, and there are rest 28 disks are also at present in that in this cluster. Is this part clear, guys? These 32 machines are still present with a replica of all these 4. Means out of this 4, there are 12 more instances, like 3 more instances which has the same copy of this 10 GB file. Means out of 32, there are 4 instances have this piece of this file. First 10 GB, then next 10 GB goes to other 4, and then next 10 GB goes to other 4, and so on and so forth. So this way distributed file system stores data into multiple machines in disks, and the master node is the one who is exchanging the task and who is allocating this into particular machines. There is a resource manager as well who is taking care of which machine is currently turned on and turned off, means active or inactive. It identifies and then allocate. If this machine goes down, then sorry, if somehow this machine goes down, then it will create a one more it will create this copy in another available instance, an available machine, so that it should always maintain a copy of a file in entire ecosystem, in entire cluster, 3 times at least. 3 copies should be there always. That is a by default replication algorithm mechanism is configured in SDFS. So this
We
is,
have a cluster of 32 machines, right?
yeah, this is for now we have. This is not a
Example.
default. We can configure it
हाँ,
at
this is
10 number.
it's an example. मुझे ये 3 वाला फिर से समझाइए, मुझे थोड़ा कंफ्यूजन हो रहा है, मतलब मैं पकड़ नहीं पा रही हूँ। थोड़ा सा ना आपकी वॉइस भी ब्रेक हो रही थी, तो मुझे
अच्छा
ऐसे
okay. So
मतलब इनके पास बैकअप रहेगा, these 4 will have 10 GB file, right?
wait, I will show you. Don't go for size, just consider this as a machine of this cluster only.
हम्म।
Okay. So replica of this image. Okay, let's understand this way. When the file has stored in this, it has stored a replica of this 10 GB into this 3. Okay. One Now we have input 3. Next, this one also, it has distributed this image into 3. Next, into these 3 images. Next, into 3. The copy of this 10 GB file is also present in these 3 machines, guys. Look here, this machine goes down. But for example, understand, if I am executing a query, select all query will fetch the data for all entire 4 GB, right? Select all query. I want to perform a query. Understand here, this is a SQL workbench Hive, which is running on the top of it. Running on top of this one. So here I have performed a query. Select all from table. This table is created on top of this file. Means the data, this 40 GB data is stored inside this table, input table. Okay. Select all from input table. We will see later how we will store the data into tables more into practical later. But for now, just to understand purpose, while I perform this query, select all from input table. Name node will see how many resources we have, and it will allocate tasks. These resources come into play master slave architecture from here, and they will go to each machines, because these all machines have RAM as well, right? These machines only executing RAM as well, who has the operational capability. Okay. So they will dive into this disk of this machine. They will find 10 GB. This slave will go into this machine and then find 10 GB file. This file, this file, and this file. This request came to this guy. This guy will allocate task to consider slave 1, slave 2 is running on top of this, slave 3, and slave 4. The slave 1 is checking into this disk bus, but this machine is shut down. Now he will go back to this guy name node. This guy will go to the name node. Hey man, machine is not present. I couldn't find the file of this name, such name. So this guy will go to resource manager. Hey guy, one resource is not available. Where have you stored that file? Then this guy will come here, talk to Metastore. Metastore has the information, which information you need. Then he will go to these 3 instances where the replica is already stored and tell this guy, hey, ask him to find this file into this, any of this, no, it will allocate this dedicated first, because he will check if he is active, then only he will pick this file from this machine. So these are also machines, guys. These are all boxes. All boxes are machines where the replicas are stored for all the split files.
So disk 1 fails, right? जहाँ पर ये
This
लिखा हुआ है.
one fail, then
And
this
ये
guy.
name node के पास गया. And then name node जो इनका ये backup है, जो ये नीचे machines बनी हुई हैं, will interact
Correct.
with these, right?
Yes.
So these
Then
disk are clusters, right? जो आपने 32 disk.
this is a big cluster now, guys. Yeah, this big size cluster.
And ये machines हमारे clusters है, right?
All machines are a collection of machine is nothing. Cluster is nothing but a collection of all machines. So this is our cluster, guys.
Where they have the original and the backup.
And the backup, correct. 3 backups are always there for each original.
Minimum 3 by default, right?
Minimum 3 by default, yes.
Now I can see okay, supposedly there's disk 1 and there's disk 2, right? But थोड़ा सा
Hmm.
S1 ये disk 1 का डेटा ये आपका ये पहले वाले का और दूसरे वाले का ये एक कॉमन है मशीन उसमें भी है जो
उसमें
आपने
भी है
लिख दिया।
because you know we have a space of 124 GB each disk. It can store other data as well, right? क्योंकि 124 GB has space they have.
आदित्य अगर डिस्क 1 डिस्क 2 डिस्क 3 तीनों फेल हो गए तो फिर
नहीं
डिस्क
तो okay, so what resource manager has done, these guys see this machine has failed already, so same time it has created a new copy into next
वो भी फेल हो
instance.
गया और उसके बाजू वाला भी फेल हो गया तो
So every time it is doing the, whenever it is getting failed, it is creating a replica at the same time into another next instance.
बट
That's why it is
साइमल्टेनियस
maintaining 3 times.
नो व्हाट आई मीन टू से इज साइमल्टेनियस सिस्टम शटडाउन या कुछ ऐसा ग्लिच आ गया तो
वो उसी के लिए तो रिसोर्स मैनेजर है ना, तो टू टेक केयर ऑफ ऑल द एक्टिव रिसोर्सेस, टू मेकिंग श्योर द रिसोर्सेस आर एक्टिव एंड प्रेजेंट इन क्लस्टर.
मतलब एनी हाउ सो मॉरल ऑफ द स्टोरी इज एनी हाउ रिसोर्स मैनेजर विल टेक केयर ऑफ एनी शटडाउन एनी फेलियर एनी
Any failure.
वर्स्ट पॉसिबल सिनेरियो।
Now your question is, if I'm not wrong, ki if all 32 goes down suddenly,
हाँ
if understand, if just assume ki all 32 goes down, okay, then there is a concept, if you remember, we had discussed in the first meeting, auto scaling. Auto scaling, whenever our instances are going down and anything is happening unexpectedly, or any uncircumstances reasons, are due to any uncircumstances reasons, it will add a new resources itself.
हाँ वो जो हम डेटाब्रिक्स के टाइम पे फिर कुछ डिस्कस कर रहे थे आप कुछ
Yes,
बता
yes,
रहे
yes,
थे।
auto scaling cluster.
हम्म।
All organizations are using auto scaling clusters because to maintain the availability and accuracy.
Okay.
Because technical glitch may happen at any time, at any code, however expensive your clusters and the systems are, it can happen anytime, anywhere. Because they
Okay.
are all connected in a network, and network can break. That's the only
Leading to
glitch we have.
worst failure
Hmm.
scenario.
Yes,
Right.
yes, that's the worst and worst case scenario. अगर इंटरनेट ही बंद है तो कुछ भी नहीं चलेगा.
हाँ पर ऐसा शायद हो चुका है एक बार मैं किसी ऑर्गेनाइजेशन में थी मुझे
हम्म.
याद नहीं आ रहा है बट कुछ हुआ था ये एक बार तो बट
डीबीएस में हुआ
एनीवेज
था ऐसा glitch.
हाँ कहीं तो था नहीं मैं थी नहीं डीबीएस में बट मैंने सुना था कुछ मैसेज हुआ था एनीवेज
हम्म.
ओके ओके सो ऑटो स्केलिंग इज द आंसर
Yes.
ओके ओके
So this is all. I will share this picture, guys. And these are all the notes also I have prepared. So I will share this, some theories to keep in mind, guys. I will share this. This is a master slave architecture. I have shared here a link. You just, if you have any doubt, you just read and go through and read it once. It will be, you'll be able to understand that. So that was for today's agenda, guys. Any doubt, any questions? You need to revise this session, guys. Please spend some time and revise this, because there might be a chance you'll get some confusions here. And I think today there might be a continuation session of your SQL. So Rajnish sir might continue the class tomorrow, guys. We will keep you posted on group. That's all.
आज इसके बाद एसक्यूएल है
No, not today. Tomorrow. Sorry.
tomorrow
Tomorrow session.
so tomorrow there will be SQL no data engineering
It is a part of data engineering, but
I
SQL
mean,
is different topics. Yeah.
I
Yeah.
mean different, completely
Yeah. Yeah.
different from what we do. Okay.
Okay, guys. See you then.
Okay. Thank you. Thank you.
Okay. Thank you, everyone. Thank you.